In this technical tutorial, I'll be covering the wiring aspects of B.O.X and just covering some of the key features that you might want to notice when examining it. Currently the battery pack is out from B.O.X as we need to change the batteries, and these switches here, which will be interesting, have not been implemented yet as they are going to be taped or glued onto the side of the battery pack. But anyways, the key feature of B.O.X here is in order to get all the motors to function the four-wheel drive, we've put the motors in parallel. This is an interesting choice as it allows us to control through one digital output here and have them both wired up to the same location like this. It's the same on both sides here, so you can see the white, which is the reverse for the motors, and the gray both correspond into the same spot. Another interesting feature is the LEDs here. As our color sensor doesn't work, we decided to implement some LEDs in order to show the referee that our robot is indeed functioning if it's just spinning in one spot. So this blue one here is to indicate that our robot is in standby mode, is waiting for us to flick a switch in order to start it. This red one here signifies that the robot is currently looking for a target. So whenever that's lit, B.O.X will be spinning on a spot like this. The green LED here would light up whenever B.O.X has found his enemy. So even if B.O.X misses it on the first turn, where this green LED should flash still for a second to show that it's indeed not just spinning on a spot because it's dumb, but it's actually detecting things. Another interesting features are going to be these switches here. These are going to be our standby switches. Each switch will basically tell B.O.X which way to rotate when we start. So one switch, when we flick it, will cause B.O.X upon his first spin to spin clockwise, like this. And the other switch, when flicked at the start, will cause B.O.X to spin counterclockwise. This will give us a huge advantage at the start, as our robot will always be able to detect the enemy within a half spin, or at least have the potential. Yeah. Another key feature which you might want to look at is this capacitor here. We've put this in parallel here to try and even out the voltage across the whole circuit. So if there's ever a dip, the capacitor should cause that to increase. This is primarily because the motors take up a lot of power, so we can't expect it to always be consistent.